All right, welcome to Wilkins Workshop. We're going to look at Fusion today and how to create a 1 cup uh, item or an item that holds 1 cup of material. So we're going to make a cone shape today using Fusion. We did another video on Onshape how to do this, but again, my 3D modeling software of choice is Fusion, and I'll show you why as we kind of go through this process. So if you've not used Fusion before, there's a lot of great tutorial videos and playlists on YouTube. 100 Days of Fusion is great. I'm going to show you some basics here as we get going. First thing we want to do is we want to create a file, and it usually pulls up this untitled, and we want to save it. So we're going to call this cup cone. So we're going to make a cone that's 1 cup in size. So the first thing we're going to do is we're going to create a sketch, and we're going to create a sketch on this bottom work surface here. And I'm going to use the hotkey C to create a circle at the origin here. And D is my hotkey to left click, move, left click, and then I'm going to make a 3-inch diameter circle. Once I'm done with that, I'm going to finish the sketch up here at the top, the green check mark. And I'm going to use an extrude this time. As I extrude this upward, you can just kind of click and drag. And then I'm going to use this tool right here so that I can taper it to a 20-degree taper, just like that. Say, okay. It's actually a negative 20-degree taper as it makes this cone. Now, there's a lot of ways to make a cone. You can make a triangle, and then you can revolve that triangle. But I like the taper method for this. Gets the job done pretty easily. Now, it creates this body over here on the side that I can right-click, and I can hit properties. And the great thing about this is it actually tells me some things about this particular item. It has a generic material to start with, but it tells me the volume of that particular cone. Now, we know that a cup is 14.44 inches cubed based on our previous video on Onshape. So I just did a quick Google search, what are the dimensions of a cup in cubic inches, and it's 14.44 cubic inches. Now, I could go through and say, here's the radius of my cone, what does the height of the cone need to be in order to get this particular volume? But again, I might not have students that are able to do that calculation. I might be dealing with middle school students that, we're just looking at cones in general and looking at their shapes. And we might just talk about scaling and scale factors in this. I'm going to use a scale factor to convert this volume to a bigger volume. So I'm going to need to multiply by 1 point something so that I scale this up. It's got to be bigger than 1 because this volume is too small. It needs to be 14.44, and this one's only 9.71. So how do I do that? How do I make this volume bigger? Well, I'm going to use the modify tool, hit scale, and I'm going to scale this by a certain factor. Now, because I'm using a cubed unit, I can't just scale it one way or another if I want it to be consistent. Now, the nice thing is I don't have to have this consistent. There's nothing in what I'm making that says that it has to be this exact same size or retain this same scale ratio. So if you're dealing with like lower age students, like middle school students or upper elementary, I would turn this off and do a non-uniform scale and just either make it fatter like this one way or the other, or make it taller. Now, for me, I would probably make it taller because if you change the Y scale, it's going to look oblong. So it's not going to look right. So I would do a non-uniform scale of this, and then I would just stretch the Z to be taller. So that's where we're going to start. We're going to start with that one first. That's not what I want. I want this right here where I'm going to go to calculator, and I have 9.71, and I'm going to divide that by 14.444, 2 fours. And so this is 67% of what I need it to be. So if I inverse this, so if I hit if I inverse this button by doing, it's not really a thing on the calculator. So I'm just going to do 1 divided by that answer. And that's going to tell me that's 1.487 times too small. I'm going to go back into Fusion. In my z-scale, I'm going to put in 1.4827. Is that the number? Just 87. If I hit OK, again, it stretches it that way. And if I right-click now and go back to Properties, look at there. My volume is now what I. So there we have our volume. We've got 14.44 essentially. And now we can do the shell feature so that we can hollow this out, but we want the shell to be to the outside because this is going to be my container. So I'd go into Modify, do the shell. I want to remove this face, and I want the shell to be to the outside of the body. So the direction is going to be outside, and I'm going to make it 0.1 to the outside of that, and I'm going to say OK. And now I know that my container, the inside of that is going to hold 1 cup of material. Now, what if you don't want it to be stretched long like that, and I want it to be a similar shape as my original? So that's what I'm going to work on now, is how do I make that? Okay, so to do that, I'm going to go back into my scaling. I'm going to delete those things I just did. So I'm going to get rid of these scale factors. Go back into what my original cone looked like. So I want it to be, you know, kind of short and stubby like this. So in that case, the math is a little different. So instead of doing this, I need to do the cube root of this. And the reason why I have to do the cube root of it is because I've got a volume. So it's a length, width, and height so that the total scale goes up by this number. So I can take that number and put it to the exponent of 1/3 or 0.333333 repeating. And now it will tell me here's what my scale factor needs to be. 1.1414 for each side of my 3 sides. So I'm going to go back into Fusion, go back into Scale, and this time I'm going to do a uniform scale, and this is going to be 1.14143. If I hit OK, and I right-click on Properties, you'll see that I get that volume now of 14.44, but it's a completely different shape than the last one. I didn't stretch the z-axis. I increased all of them by 14%. So if I make a 14%, 14%, 14%, then all of a sudden my total dimensions went up by 48%, whatever the number was that we needed to be bigger. I hope that makes sense. Again, when you're doing like square units, you would do it, you know, you take the square root instead to find the scale factor. So if you want something to be twice as big an area, you don't double the length and double the height. You either double one or the other, or you have to do like the square root of 2 bigger one way and the square root of 2 bigger the other way in order for that when you square those, it's now twice as big of the area. Because if you double both, it's 4 times the area because you double the width and double the height. You know, you don't have 2 times 2 or a scale of 4. So again, I'm not really sure where that's taught content-wise in math, where you're doing scale factors and looking at areas, and how, you know, if you double the length, what's it do to the area? If you double the length and the width, what does it do to the area? But again, I think those are concepts you can bring in to the problem-solving process of something like this. So I hope that makes sense. The last thing we're going to do is we're going to then export this to 3D print. So really simple in Fusion, you can go to, first I'm going to save it, and then I'm going to go into Utilities, and there's a Make button. And I always uncheck the Send to 3D Print utility. I don't want to send it there. I just want to save the file. Again, make sure your unit type is at millimeters. That is for the slicer software. Most slicers want the object that you're importing in millimeters. That's usually their default. So that's what we're going to do. We're going to select this item, and then we're going to say OK. Then we're going to name it, cup cone. And it's going to be saved to my downloads folder. I'm going to hit save. And now that's going to be ready for my slicer. I'll have another video on how to import all these into a slicer. We're going to 3D print them, and then we'll be ready to go for some testing. So hopefully that made sense. Have a great day, and we'll see you next time.